Good morning once again, ladies and gentlemen. This is Anand on day 5 of Industry Samurai Consumer Awards. Uh, a few moments ago, you were looking at a conversation that we had with Ms. Sugita, Consul General of Japan. We had a very interesting conversation, a very encouraging and inspiring message from Ms. Sugita to India's manufacturing sector and to us about Indo-Japanese relations. Now, in continuation with that, session, we have a topic that again speaks from a global perspective, as well as the impact that it is having on India's automotive sector. You've guessed it right. It is about semiconductor manufacturing and the shortage of chips or semiconductors that has occurred in the last 1 year, also being called by some experts as chip famine. Now, what is chip famine? Chip famine is something that has, you know, occurred in the past as well. Uh, for example, the 2011 Fukushima earthquake and the 1993 Sumitomo company's chemical explosion, for example, are two instances of natural and man-made disasters that brought the global chip supply to a halt. Then, the last year, uh, what happened was that at the peak of the pandemic, around March, April last year, uh, the demand for consumer electronics skyrocketed for the obvious reason of people needing devices for work from home. Now, uh, spooked by the crisis, the lockdown restrictions, automakers did not order for chips for semiconductors for their cars. And this made the semiconductor manufacturers, a lot of who are based in Asia, divert their manufacturing, their production lines towards consumer electronics, which was booming at the time. So now as you know, the product cycle, particularly in semiconductor manufacturing, is very, very long. So once you divert your production lines to a different industry, it is very hard for you to again redistribute your assemblies and production uh, to the original industry. And that has been at the genesis, at the core of this crisis. We have experts in the industry who will tell us a lot more about the supply chain, about the manufacturing, about India's position in the global manufacturing supply chain, global semiconductor manufacturing, and the supply chain landscape. Let me introduce our speakers to you. We have Mr. Yogesh Dadke, Asia Pacific Information Technology Leader at Adient. Yogesh is a hands-on technology champion with focus in designing the global IT strategy across business verticals, competencies, and functions. Yogesh spearheaded global teams in multinational and Fortune 50 organizations, steering IT through a range of digital transformation initiatives, including modernization, IT P&L, digital innovations, and smart factory manufacturing. Smart factory manufacturing segmentation-based deployments. Yogesh is a recipient of over 125 awards for technology innovation by international and national forums, including IIT Powai, NASCOM, CII, Liverpool, and MIT, and others. Equipped with organizational development OD certifications, Yogesh follows the servant leader style, and his positive attitude helps deliver the best outcome even during challenging situations. With a strong sense of philanthropy, Yogesh has been associated with NFBM Jagriti School for Blind Girls, Alandi, Pune, India, and helps empower the schoolgirls for their basic needs, education, and employment. Welcome, Yogesh. Let me introduce our another speaker to you, our second speaker to you. We have Mr. Magesh Srinivasan. Magesh is a global thought leader in future digital strategy design, consulting with CXOs and boards of management. He is a speaker on transformative technologies of the 21st century. He is also the founder of datamentor.co.in, based in the Silicon capital of Asia, Bangalore. He has worked extensively delivering solutions to complex projects in his career spanning 23 years. He has a global exposure He has traveled for work across 38 countries in 100 cities. He has succeeded in pioneering leadership roles with the Fortune 100 companies and has been responsible for P&L, people, processes, and pioneering technologies. At the moment, he is also an independent management consultant focusing on corporate strategy integrated with ESG and digital transformation. He is teaching digital transformation and ESG courses to the MBA batches at the Indo-German Training Center, Mumbai. He is also a mentor for startup founders and social business owners. He is a graduate of the MIT Sloan School Executive Program. He has worked with 6 Fortune 500 global brands, including Bosch, HCL, Sony, Blopung, ZF, Wabco, and Black & Decker. Thank you so much and welcome to the forum, Magesh. Let me start the discussion with the first question addressed to you, which is, can you take us to the genesis of this crisis? How did this chip shortage happen? Magesh, over to you.
Thank you, Anand, and thank you for the opportunity to express my views. So the semiconductor industry has, evolved over the course of, in fact, all of the electronics development that we saw in the 1950s and 60s began because of the semiconductor business starting off. And while the innovations were started from the United States of America, soon we saw Japan catch up and Europe catch up. And between the US, Europe, and Japan, and today Taiwan, there is huge amount of IP, there's huge amount of manufacturing capacity, and the entire global supply chain of semiconductors have been evolved. Of course, today India is a very big design powerhouse and produces a lot of designs for the semiconductor industry. But unfortunately, all of these designs are owned by foreign investors who have established companies in India, and we are only offering design services. But let's first demystify and understand what is exactly a semiconductor manufacturing process so that we can come to elaborately identify what are the root causes of this famine, right? So a chip, right? If you look at this prop that I've brought, this you can imagine is a silicon wafer. And this is a brand story of from the sand, that's silicon, all the way to the brand. The iPhone, for example, is the brand. Now, when you make a silicon wafer, what you're essentially doing is you're creating out of sand a physical substance. And this physical substance, such as a wafer, in the form of a wafer, uses a process called as photolithography. And it is exactly the way we print newspaper or print any kind of printing material. We have to print on the silicon wafer, very high precision using nanotechnology, what is known as process nodes. Now, in the very advanced chips, we use what is called as extreme ultraviolet wavelength of light in order to print process nodes which are less than 7 nanometers. And anything above more than 7 nanometers or 10 nanometers and above uses what is called as deep ultraviolet. And as you can see now, we are dealing with nanotechnology, which is extremely precise and therefore highly complex. Now, in terms of extreme ultraviolet lithography, these machines are manufactured by only one company in the world, which has a dominant position. And this company is based in the Netherlands. It's called as ASML. ASML last year, because of the pandemic, was able to produce only 31 of the lithography machines. And these lithography machines then are supplied to the world fabricators who are based in Taiwan and other parts of the world, Japan and so on. So, for example, if the Taiwanese fabricator wants to buy today from ASML, it's not an off-the-shelf order. It typically takes at least 1 to 1.5 years for these machines, capacity of producing these machines to be matching the demand of the global chip fabricating manufacturing plants in the world. So the lithography machine called TwinScan, which is manufactured by ASML, which is today almost a $13 billion company, requires almost 4,000 suppliers in order to make one machine. And of these 4,000 suppliers, 300 are based in Netherlands, 100 are based in Germany and Europe, and very important players like Carl Zeiss, who actually produce the optical lens required for this. And the remaining are all in the North of America. Now, we were hit by two things in the world. One, the pandemic, and second, extreme weather events. Extreme weather events caused some of the suppliers in the US to shut shop, and the fabrication process was delayed. And because of the pandemic, Intel, Huawei, and every other large player, they ran their order book down on the Taiwanese fabricators, which again led the Taiwanese fabricators to reduce the forecast that they gave to ASML. So this is where the problem started. And if anybody has read Mr. Goldratt's book called The Goal, which was published in the 1980s, he speaks about the theory of constraints in a manufacturing process. So if the entire capacity has to be impacted positively, then we need to identify the critical path. In the semiconductor manufacturing process today, the advanced chips, which required extreme UV lithography, are all dependent on the TwinScan machines coming from ASML. And these advanced lithography machines are not available from any other player in the world, unfortunately. And this becomes a critical path. Now, in order to expand the capacity, it's not enough for just expanding the fabrication plants all over the world, unless and until you have the ability to produce silicon wafers and create process nodes of high precision. And we are talking about very high precision, and that's why extreme ultraviolet. At this level of nanotechnology, we are dealing with the size of what viruses exist at. That is the level of precision required. So it's not easy to make these. And it's not everybody's job as well. So it's not only a matter of investment of time, it's an investment of know-how over 2-3 decades of making many mistakes and then perfecting this process. Now, Japan, Nikon, Canon had a big amount of advantage. But unfortunately, when it comes to extreme UV, they are also have a capacity constraint. They do not have the expertise in that level of technology. Therefore, Japan is good at the deep ultraviolet and everything beyond, whereas ASML is very good at EUVs. And this entire EUV technology was developed as a consortium in the US in the 1990s. And then, with ASML coming to be formed in the Netherlands with the help of Philips receiving funding, they have a predominant position with a $300 billion valuation on the stock market today. So that's the crux of the matter. And we can discuss further, having understood this basic manufacturing process and supply chain.
Thank you, Magesh. Yogesh, your take?
Well, Mangesh, has taken us through the complete journey of, and very less, probably very less contribution from my side in that complete, explanation. However, I'll tell you in a very short note, probably a couple of sentences from my side, what has happened right now as a problem statement from automotive industry perspective. Whenever we used to place an order, it used to take about 8 weeks to 12 weeks kind of time frame to get the delivery for the semiconductor finished good component for a chip, for that matter. Right now it is 18 to 20 weeks. Now when I talk about 18 to 20 weeks, it gives me a very shocking treatment to either maintain the inventory out of my pocket in my warehouses to make sure I cater the demand which is from the market. And also, we must understand that if we compare about a decade ago situation where ICE engine was on a prominent, today is EV and ICE both together. So the market demand of vehicles, automotive vehicles, typically has shot up by 40% odd. And with a deficit of 18 weeks to supply those semiconductor or to have those chips at my factory, it's a it's not even a chicken and egg story. It's is where should I put my eggs first? That's the story.
Thank you, Yogesh. That's fascinating. Absolutely. I should have asked this before. Could you give us an idea of what are the typical places or areas or utilities where semiconductors are needed in automotive?
Well, right from your engine component to your seating component, your battery components, lighting components, wiring components, connectors, um, almost everything is chip based right now. Rather,
Wow.
if we talk about automotive market, it's about 30% of metal and 80% of electronic goods. And with heavy usage of automation, sensory mechanisms, the use of chips in car making and its ecosystem, car as ecosystem, has gone up by 62% up in last 1 decade. So everything is electronic based, everything is chip based. Your dashboards, your pilots, the screens, your co-pilot sensory mechanisms, your sensory mechanism for safety bags, and almost every, even seat belts, those have either some or other trigger sensory mechanisms based in it, and it has a chip in it for intelligent processing.
Wow. Okay, that's really something for us, um, in the tertiary sector to understand. I have had a fair idea of this, but the extent and the magnitude of the use that chips have come to be deployed is enormous. If you could, gentlemen, could give us an idea, our readers, an idea of what are the differences between the chips used for automotive and the chips used for other sectors, especially consumer electronics, which I think lies at the core of this issue. Yogesh?
Yes, I mean, I will be in position to tell the utilization of it. Maybe Mangesh will be in position to tell about the manufacturing process of it. He can put that light. But from the utilization perspective, as Mangesh mentioned, there are a couple of types of chips. Maybe ultraviolet, reading based chips, violet manufacturing based chips, and every chip which is used or manufactured has some or other potential from utilization, whether it's consumer electronics, whether it's automotive electronics, or whether it's hardcore machinery mechanisms. So with that, of course, I have very limited knowledge on it. I'll hand over the baton to Mangesh from my side. Thank you.
Thanks for your modesty and humility, Yogesh. Magesh, what is your view?
Sure. Thank you, Yogesh. So, Anand, what I would want to do is first try to explain, what's the framework in which digitalization is happening in the world, because we need to understand where are these use cases coming from. Why is this huge demand for electronic goods today, post-pandemic, right? So what I've created is a paradigm called as a human, data, and machine paradigm, or what I call as Hudama paradigm. Now, when human beings start to use machines, what is co-created or procreated is called data. And today, the world runs on data. Data is what creates money, right? It's not the fiat money printed by government, which is actually running the economies of the world anymore. But it's the data that's created in the computing systems of the world and the platforms of the world, which is actually driving the economies in the world, the borderless world. So having said that, now let's take the automobile as an example, which Yogesh mentioned. So the automobile, as compared to the aeroplane or the space shuttle has 2 million lines of code. The aeroplane has 20 million lines of code. The automobile has in excess of 200 million lines of code, which essentially means to process these 200 million lines of code, I need about 125 to 150 microcontrollers, which are embedded in the automobile, advanced automobile. And if I want to achieve fully autonomous vehicle, which means this computing power has to further increase. And this is what is driving the demand for advanced chips, not just any semiconductor base, because the semiconductors and the intelligence required to run a calculator or a smartphone is very different for high precision autonomous driving, for example. So if I am putting a chip required for stereo visual intelligence application in a fully autonomous vehicle, then the semiconductor base, the integrated circuit and microcontroller, microprocessors all have to work at a very low power requirement. So just imagine the human brain. We have analog architecture, and even if you're hungry, you can still operate. The brain still operates, does not collapse. And now semiconductors have to match that kind of a operating principle where you are consuming very less power, and now they're pushing the boundaries of science. They want to achieve power wattages less than 4 watts. And in order to achieve this, that you work the semiconductor at a very low power consumption, then you have to increase the number of process nodes. At the moment, we have more than 10 billion transistors in a very advanced chip. 10 billion, can you believe? And that's just one chip. So this is only going to increase with the onset of quantum computing. And Gordon Moore's law from 1965 until the turn of the millennium was valid up to 50 years. Every 2 years, the number of transistors kept on increasing and the cost of the chips kept on falling down. But now you see that since you've entered a new paradigm and you're going, sub 7 nanometer and beyond, you will see that the cost will slowly begin to increase with advanced functionalities. And today you want everything to be connected with very low power requirement. You have very low power Bluetooth. You have very low power consumption on Wi-Fi enabled devices. Your smartphone has more than 26 sensors, and all of them are operating on the battery that you charge, which lasts for more than 8 hours today. So now can you imagine the brain computing power required in a small chip and the multiple chips that's embedded in a system on chip, SoC, and then make all of this work is not extremely simple. It's highly complex and orchestrated through a very, very diverse global supply chain. And it's like an orchestra, music orchestra. So even if one component is missing, you will not be able to produce the intelligent machines that we are currently using in the world today. And this is the complexity of the use cases that's coming about. And we are creating digital twins of everything. We are creating digital twins ourselves, digital twins of our cars by connected cars, digital twins of aircraft flying in the air, digital twins of our Netflix account, whatever, right? So everything is computing power. Every digital use case has got a physical construct. And the physical construct eventually ends up in the neuron of the world. And the neuron of the world today is the semiconductor base. That's the fabric of intelligence.
I'll take it on a little bit on a lighter note. As you mentioned on the physical twin, we are also due to the supply chain issues on the semiconductor side. One of the automobile manufacturing company very well known is going towards physical twin, and instead of putting a digital rear view mirror, they are putting a manual rear view mirror, and the digital rear view mirror will be supplied to the purchaser or the buyer in next 18 months, and they are offering some discounts on it. So they're going, I mean, the positioning of the product and how to deal with the challenge is a learning process, and the challenge what industries are going through. You're on mute, Anand.
Absolutely. That's really interesting. And moving to the second part of our discussion, where we could, for informing our readers about the global value chain of chip manufacturing, to give us an idea of where the major locations are in terms of consumption, and manufacturing, and raw material, about which very little awareness is present outside, the end consumer industry. Let me share my screen with you in giving an idea of the global semiconductor value chain. This is from semiconduktorsassociation.org, and just to inform our readers as to what are the major steps involved. So as our readers can see, that the step one of research and development happens in North America, and then we go to the raw material and silicon ingots that are cut into wafers. That happens in Asia. Then the third step again goes back to North America. So this is South America, where wafer is cut into finished water, and there's a lot of debate going on in America about near shoring these locations. For example, in South America, and especially during the pandemic, there was this talk that these sites from South America where wafers are cut should be brought closer to Northern America. And then the fourth stage is when wafer is sorted and cut into dies. Then we go back again to Australia. As you can see, this is very interesting. This is back and forth, the whole global supply chain. And then from there, the sixth step is again in South Asia and Australia. Seventh is back to China. And eighth is the market which exists primarily in Europe and the US. So this is really interesting from a very, very big picture point of view. But I'll turn to the experts in this case, and I'll start with Magesh. Give us an idea of the global supply chain of semiconductor manufacturing and how this came to be.
So there's a lot of history in the development of semiconductors, and as always, Anand, a lot of investment in the early days came for defense applications, and because of the need for more advanced defense machines and defense systems, there was investments coming from the US government. A lot of these investments is what is paying off, in advancements that we can see in companies like ASML, which were literally, incubated as part of the national laboratories of the US in the 1990s timeframe. Now, companies like Fairchild Semiconductors, which is, the inspiration for Intel, and Japan, getting inspired by the US, started a whole lot of investments into semiconductor business, and has a huge lead when it comes to, very advanced microprocessors and microcontrollers, and also the lithography machines, which I just mentioned in the first part of my discussion. So the transition of very advanced semiconductors is, of course, moving from the West towards the East. And what today is mainstream in terms of development is trying to improve the power consumption on every single chip. That means reduce the power consumption, whereas increase the processing power and thereby the intelligence, the unit of intelligence, so that these semiconductors can become more and more intelligent for the world's computing requirements. So in net, you have US, you have Europe, you have Japan, the upcoming China, India as a design hub. This is how the entire supply chain looks like at the moment. And Taiwan is a very strategic location. And this is one of the reasons for geopolitical tension between the US and China, because without Taiwan, the entire global supply chain today will be at risk. The US realizes this is a huge risk. And therefore, it is pertinent to mention that geopolitics play a very big role. And as far as Europe is concerned, Europe has invested quite a bit, and companies like ASML, because of the support of Philips, have been able to come up to global standards and become the world supplier for lithography machines. And companies like Carl Zeiss, which actually make the high precision optical sub-assemblies required for lithographers, are improving their technology as we speak of. But you will see as the semiconductor evolution progresses that apart from silicon wafers, there are new technologies coming about, such as carbon nanotubes and graphene, which will become the substrate elements moving away from silicon. When that happens, you will see a new supply chain of intelligence being built on the semiconductor base, and the huge paradigm shift happening from semiconductors as we know it into something that we do not know yet. But when things like carbon nanotubes and graphene starts to push the boundaries of science and technology in such a way that the form factors we have, the form factor of a smartphone, the form factor of an electrical switch, the way electricity moves, and the intelligence of electrical circuits, all of this will change. And that is coming about in the world. The process has already started. And therefore, there is a very big transition from the industrial age manufacturing-based setup to the next gen future of our future in terms of semiconductors. So at the moment, there's a big flux and there's a lot of activity happening in Asia.
Thank you, Magesh. Yogesh, your views on the global supply chain of semiconductors?
Well, it's as my background also suggests, that's what I try to put and say, it's going to be the impact analysis as automobile manufacturers are going to face the challenge for procuring finished good, that is chips, and then deploy in their vehicles for the delivery. Of course, small mechanisms like what I said, creating a manual twin for the delivery, from the delivery perspective, just to have a, for example, one of the Japanese OEM, they are delivering the vehicle without GPS, digital GPS. You can plug in external one, but these are the ecosystem issues that we all going to face at least for next at least till Q4, calendar Q4 of 2022. So from today, if we talk about, I'm talking about 6 quarters, that's going to be the issue pertinence area. So to do that, from a manufacturing perspective, I need to make sure that my SCM and my ecosystem SCM is on track, not just from the planning perspective, but also from budgeting perspective, because these are all capex savvy decisions. Now, capex savvy decisions, they attract funding. In turn, there is always a lag of when will I get my returns. That's where the board decisions are going to play a very important and critical role while calculating the EBITDAs of the mechanisms and P&L of the mechanisms and etc. So the borrower mechanisms from financial institutions is going to go in an upswing. That's where the organization, Magesh also mentioned the geopolitical issues That's where government also comes into the picture, and we see some of the ecosystem predominancy at India by RBI, by government decisions to give or lend a certain amount to the organization for the manufacturing to have their holding capacity strengthening from X to Y in the current situations. This is just one leaf out of the ecosystem or the supply chain. Then giving that clear message towards our consumers that, boss, we understand your problem, but to not just while understanding perspective, but also we are ready to cater you. The catering will be in -1, in -2. So have that time frame, that thought process in a mind. As a consumer also, I must understand that, I want a phone right now, I want an iPhone, I must go for n-1. That will be easily available. If I go for n-2, I'll get it in a discount. But that's a consumer mindset. For ecosystem, the supply chain mindset perspective, when I talk about the transistor mechanisms, those are going to play a very critical role in getting it addressed. More or less Q4 22. Thank you.
Yes, that's a very optimistic message. And as a matter of fact, you're right that Indian consumers have to be more tuned into this problem, this challenge. And the government, on its part, actually is in talks with manufacturers like TSMC and AMD and Intel for promoting semiconductor manufacturing in India. But they are working on this package that is yet to be announced. But that is what the government or the public capital is doing. From a private enterprise point of view, I want to know from you gentlemen as to why and how the semiconductor manufacturing industry is so concentrated in different pockets of the world. And I'm asking this question from an Indian point of view as to how can we leverage what positions are either unfulfilled, or where is it that we can position ourselves in the entire value chain. So if we look at the overall semiconductor industry, US leads the world in developing, selling semiconductors, and in consumption also. Manufacturing is concentrated in Asia, where Taiwan and Korea, as per reports, account for 83% of global processor chip production and 70% of memory chip output. Now, when it comes to the foundry market, TSMC leads the world and is accounting for 54% of the global foundry revenue. This entire market is concentrated, the manufacturing sector is concentrated in Asia, especially in TSMC. And before I finish that question, I want to share this very, very interesting article's insights with you, which I recently read in NYT. It was written by Thomas Friedman, who wrote The World is Flat. So he looked into why and how TSMC became such a big powerhouse in the last 2 decades of semiconductor manufacturing. He said it is about trust. It is the fact that other companies are not able to, even Intel has not been able to compete with TSMC, because TSMC has built these networks of collaborations and trust with the best technology companies in the world, whether it is Apple, whether it is Samsung, whether it is any Chinese brand. They have been able to build these networks of collaboration, and all these big technology brands trust TSMC, and they're able to have infrastructure for future technologies well ahead of time, because they are well aware what these major brands are up to in the next 5 to 10 years horizon. So considering all these aspects, why do you feel that chip manufacturing is concentrated in fewer areas, and how can India leverage on this aspect of supply chain? Magesh?
Thank you, Aanaand. It'll be very interesting to note for all the Indians on the call that India actually had a semiconductor complex limited in Mohali, which was an investment made in the 1960s, 70s. And there was a point in time when Fairchild Semiconductor had considered India as their investment location. Of course, this was the pre-91 days, the license Raj days, and therefore we scared the Americans away. But today, the same semiconductor complex limited has become Semiconductor Lab under the government of India, and it is working on chips. However, one must note that, like everything in life, it is not just about money, it's also about process know-how and execution precision. That means your ability to achieve zero defect. And to attain zero defect, it means that you have spent at least a decade or two perfecting the supply chain that can deliver the inputs required on the bill of material to the manufacturing plant. And the manufacturing plant has completely a process that is zero defect, and therefore the input, the process, and the output are tending towards zero defect. And this is not just achieved by money alone. It's achieved by know-how execution over long periods of time, typically 1, 2, 3 decades. And this is a disadvantage India today has, because we started very well, but because we only liberalized in 91, and by 2005 or so, that company which was in Mohali was closed, and now is just a government laboratory. So we must remember that design powerhouse of the world is India. All of the VLSI is happening in India. So do we have the intellectual gray matter content in India to make this happen? Yes. Then what is required? Money. Money is a function of business plan. And when it comes to investment into futuristic national strategic projects, it has to be an investment of the government in partnership with the public and private enterprises. So it has to be a public-private partnership framework with which India is working, just as we did for the National Highway Authority of India project, just as we did in the telecom sector, just as we did in the education sector. Everything has to be an investment between the government and the private players, with very clear strategic guidelines and a very strong champion with a vision to drive the strategy until India achieves, dominance. Now, if you remember, when India was refused the technology for cryogenic engine, we made it happen. We made it happen. When India was refused the technology for nuclear fusion and fission, we made it happen. So we have the Indian brain available to make things happen. However, there has to be political vision, political understanding of how long this takes to achieve, and also very smart collaboration with US, Europe, and Japan. If we can bring your US, Europe, and Japan to help India become the next gen semiconductor and intelligent manufacturer of the world, it is in everybody's interest to see India grow as the more fair player in the global political stage, vis-a-vis China, which is extremely polarized and trying to dominate with its manufacturing prowess, which is the reason why now the semiconductor supply chain is being constricted because of geopolitical reasons. And that geopolitical vacuum India can occupy. We have the people, we have the infrastructure that can be that can be brought for the manufacturing setup, and we have the intellectual capability to drive. But in the beginning, we need the know-how. We need the know-how. We need the technology transfer in order to gain time. Otherwise, we have to invest the next 3 decades trying to achieve what has already been achieved by the world players. So that is where we are, Aanaand, as far as India is concerned.
I'll
Thanks,
add a
Magesh.
line.
Yes.
I'll
yes.
add a line to that, just from the statistics perspective. When we talk about chip data transition processes, every country files their patents, And just from the statistics perspective, Japan holds 30,500 patents for the data transitions in the chip. Okay. But and then I went further into it. How many people from India wrote a paper in it? Almost 18,000 are co-writers in those papers. So do we have the brain to do that? Yes. Do we have the ecosystem to do that? No. So we need to build the ecosystem to do that.
Great.
Thank you.
Thank you, gentlemen. There is an audience question that if you'd like to take. N. Tanwar asked from Ludhiana that it looks like from the conversation that a solution is not near or not close for this crisis. So how can the automakers plan better their supply chain and production in the future to avert and face such crisis? Yogesh?
Yeah, I can take that question, but a little bit on a lighter note, I'll take it. I may not be, in position to tell how you and your organization should deal with it, but I can tell in a little at the higher side how automakers, by taking, typical names of the organization, for example, Renault. Renault has stopped the large screen display screen. They are only giving a 4 inches display screen right now, which is behind your steering wheel. So you, as an automotive manufacturer, they have to come up with some out of the box solutions to cater to the situation. That's one. Now, can it help? It will help. Will it affect brand value? It is going to affect the brand value, but you're going to get money today. So ROI today versus brand value 5 years from now. Is there a process to build your image in a market? Yes, you can build that image. So it's a seesaw that every car manufacturer will have to play that in a role of thought process, and that's where the leadership roles, strategies are going to play a very wider role.
Thank you, Yogesh. Magesh?
So I'd like to offer 2-3 perspectives. The first is that now is the time post-pandemic, because the digitalization of the world is come about and is mainstream in everybody's life, both consumer, professional, public, and private, including the government. It's important to understand that digitalization can only succeed if the semiconductor, which is the fabric of intelligence and all digitalization, is available and is available for an affordable price point. And the way to make that happen, perhaps, is to do what was done in the TV industry. When the LCD became extremely unviable, instead of every player setting up a LCD manufacturing plant and trying to lower the cost, we saw consolidation of LCD manufacturing. So, for example, Samsung and Sony came together. They compete, on the market as a brand, but they came together in order to invest in a plant which produces the LCD, which is the reason why such moves is the reason why the LCD panels are affordable. And today in India, you can buy a smart television, a large 45, 46 in less than 40,000 rupees. So similarly, in order to reduce the price and increase the availability, the first point is to standardize, and through standardization, commoditize. When commoditization of the basic chips happen, then you will be able to have off-the-shelf solutions for any car you manufacture, any subassembly, embedded subassembly that you manufacture for the car, and that supplier of that particular embedded subassembly has got multiple options in order to swap the semiconductors, microcontrollers, microprocessors in whatever he has to deliver to his or her OEM, right? So today, everybody is doing their own subassemblies, their own customization, and their own individual, supply chain, which is extremely expensive, and we end up in a situation where nobody wins. And this is the situation we are in the pandemic. And now we saw in the pandemic one quick example of vaccine being manufactured by everybody in the world because the know-how was shared. It was a collaborative approach. Everybody was on a war footing. And therefore, in India today, you have more than 100 crore people vaccinated. So we have to go to a standardization, commoditization, industry ecosystems, and then supplier ecosystems, led by OEMs and led by government. Government has to incentivize industry ecosystems and incentivize standardization and commoditization. That's the way to go. And then the differentiation is at the brand level, how you deliver the brand, how you deliver the experience. So one can differentiate. And if everybody wants to create their own supply chain and try to dominate that supply chain, then nobody wins, unfortunately. And that's the truth of the post-pandemic world.
That's so true. So true. Exactly. And this is where I feel that closing remarks are needed from you gentlemen, because the whole idea, the intent behind this discussion was to raise awareness among our manufacturers for this thing, because the market is so lucrative. Suddenly this pandemic has increased demand for consumer electronics with WFH. It was so sudden and it has blown up, and the companies and manufacturers and countries who are already present in the value chain of semiconductors have really benefited. And Indian manufacturers are keenly looking at this space, especially the aspiring ones, the newer ones who are already, let's say, working for automotive or aerospace, who already may have the machines, but they don't know how to go about it, because India does not have a legacy value chain or supply chain that favors the Indian manufacturers. So they want to know how to start in this direction. So from that perspective, I'd like a closing remark from you gentlemen on how an aspiring manufacturer who's listening to us today, how can he develop products, how can he plan in the next 5 to 10 years horizon as to make the best of this wave of electronics and semiconductors. Yogesh, your thoughts?
Sure, I'll go back to my Stephen Covey's books, like 80% planning. And that's where the things are going to start right now. Planning, planning, planning. Sometimes you have to plan to the extent that what if kind of objectives, and with plan A, plan B, plan C kind of activities. And that's what everybody, including ourselves, we are doing. And that's why we are in a position to be in the place where we are in the market. Second, I'm going to borrow a word from Magesh's lines to don't compete, or competition is not a survival. It's collective collaborative efforts from within the organizations and with the external organizations to become a champion. Coexistence is going to be the most beneficial mantra for everyone. I mean, we like to compete, there is no doubt about it, but competition and healthy competition, there is a huge difference in it. So, try to go towards a healthy competition so that it becomes a win-win situation for everyone. And the last but not the least is take care of your people. I think I repeated that message in my earlier on 12th December conversation also. Taking care of the people helps. A government takes care of the people by rolling out 100 crore vaccines. It's our responsibility also to stand by our own people in the organization during these challenging times.
Brilliant, brilliant. Thank you so much. Magesh?
So my take is a bit different, Anand. I think India now needs to leverage its very strong position in defense and demand in defense, and its strategic relationship with the European Union, the US government, and the Japan government. And all of these three governments are, friends of India, and they need India for strategic reasons. And there are many countries who are dependent on, the defense demand of India. So we should now use our political power and strategic position in the world to leverage knowledge transfer, IP transfer as a barter deal. So if you want access to market in India, you have to provide know-how. This is what China did. Nobody has access to China in the years they were growing without knowledge transfer, know-how transfer. That's how China became the world's factory. Today, we are #2 manufacturing destination for smartphones in the world. We are also the #2 market for smartphones in the world. So we have inherent strength on the consumer side. We have inherent strength in the manufacturing competency and capability of India, but we need to beat time by having the IP transfer and knowledge transfer from Japan, Europe, and from US. And this is possible. This is possible. Once we have the know-how, then we have the Indian manufacturing talent and the entrepreneurial talent available to produce things in a frugally engineered way, so that we can achieve what needs to be achieved for India and for the world. Thank you.
Wow. Wow, this is just what the doctor ordered. This is just what the readers wanted to hear from you, gentlemen. Thank you so much. This reminded me, Yogesh, you mentioned Stephen Covey's name, and this reminded me of an opportunity that I had years and years ago of speaking with him about his book that he was going to come to launch in India, The Seventh Habit. But he unfortunately could not come because of health reasons. This is 2009, and the interview is still there on Business Standard. So one thing that kind of harkens back to this discussion, something that he said. So I'd asked him that, what should I do if I want to become the CEO of my company, or let's say the prime minister of this country? So he said that start with becoming a change catalyst. Become a change catalyst, build your circle of influence, and then people will start to follow. Obviously, I didn't ask it from my perspective, but I asked it from perspective of a whole community, of a whole industry. And that message is what also came out of this discussion today, that the Indian industry has to become a change catalyst. It has to create its own value, and that's where it will start to enter into this domain. And one more thing that he said, I asked him, what is the best thing that you like about Indians? He said it is their polemic nature. It is their nature to discuss and argue about everything and come up with insights. And I think our discussion today stood really strongly in that area of being of a polemic nature. And that is thanks to you two gentlemen. Thank you so much for a very, very beneficial conversation we had today.
Thank you so much. Thank you for the invitation.
Thank you. Have a good day.